So today's webinar, we're exploring the differences between cellular IoT SIMs and consumer SIMs. As I'm sure everyone's aware, there's a lot of changes in the landscape of how a SIM card can be used these days, and especially how it relates to IoT. What we want to do today is some myth busting around that, some education on what's capable, and help you ultimately choose what the best SIM card option is for your business needs. My name is Jonathan Rosenfeld. I'm the head of marketing here at Hologram. I'm joined with our CTO and co-founder, Pat Wilbur, who's going to be leading the conversation today. He is certainly a subject matter expert in this arena. And what we're going to be covering today is essentially, what does the current landscape look like? What are consumer SIMs and cellular IoT SIMs and how they differ? Where do they compare from connectivity and the management piece? And then really the heart of the matter, how to decide what's best for your business. The remote provisioning use case, what to look out for in a high data volume use case. And then we're going to close out answering some of your questions. So with that said, I'm going to go ahead and hand it over to the illustrious Pat Wilbur, and we're going to get right into this. So with that said, take us away, Pat.
All right. Thanks, Jonathan. Again, I'm Pat Wilbur, CTO here at Hologram, and excited to be with you and excited that you could join us. We want to talk a little bit about what's coming down the line for SIM cards. There's some interesting innovations there. And first, just to kind of characterize, two different categories of SIM cards here we have on this slide: consumer SIMs and cellular IoT SIM cards. And want to talk a little bit about that. So we're going to get started with that first. So SIM cards are subscriber identity modules. They were actually initially designed for consumer devices like phones and tablets. And what they do is they authenticate a device onto the cellular network. They're not just memory cards, but they are small integrated circuit cards. So they're basically small computers that are used to implement what's called a zero trust paradigm for device to network identification. And actually the SIM standards are such a good authentication model that we've continued to iterate on those core concepts after decades of use in the cellular industry. And we've extended those beyond just consumer devices. So there's certainly a lot of overlap between a consumer device-oriented SIM card and an IoT SIM card, but there are some differences, and there are some ways where SIM technology has really been iterated and innovated to solve some of the unique problems and provide unique solutions for IoT. Just a quick note on some terminology. When we say a profile, like on this slide here, what we mean is a virtual representation of what traditionally would have been just a physical SIM card. So all the credentials, the information necessary to authenticate with a network, that's what a profile is. In an EUICC or eSIM environment, EUICC is the specification for some of the technologies we're going to be talking about. But in that environment or an eSIM environment, profiles are intended to act like a physical SIM card would have. And you can select those without the need to physically replace the SIM card. So that's what we're talking about with a profile. Provisioning just simply means loading the appropriate profile that you need. So with that, what are the differences between consumer and IoT capable eSIMs? Consumer cellular devices typically use just one profile at a time, and really most of the time just use one profile and are not switching profiles. Consumer eSIMs also assume that a user will be present each time that provisioning is occurring. So that requires user interaction to provision a profile onto that SIM card. For example, if you think of an iPhone or an Apple Watch, the user might scan a QR code in order to choose the profile and initiate provisioning to get that device online. IoT SIMs, on the other hand, typically have instant on connectivity. So this is known as a bootstrap profile, or it's a profile that provides connectivity right out of the box. So you unbox the SIM, it has the credentials necessary so it can connect to a network instantly. IoT SIMs that then support this EUICC standard that I mentioned, this eSIM standard, can be remotely provisioned and re-provisioned with profiles without any further user interaction. So in some cases, like a Hologram has what we call our dual core SIM. It's even possible to have multiple eSIM profiles loaded into that SIM and to have software running on that small computer that is the SIM card to be able to autonomously switch between those profiles. So that's a key difference between cellular IoT versus consumer cellular SIM cards. And that is that idea of a bootstrap profile, remote provisioning, and even maybe having multiple profiles that you're switching between. Both consumer and IoT SIMs will come in, eSIMs will come in multiple form factors, including removable plastic or embedded soldered on chips. So they do have that in common, that they come in multiple form factors. So we're not just talking today about the embedded chip you solder in a device. It can be whatever form factor your device needs. But these are kind of the key differences in those two categories of SIMs. And yeah, we're gonna dive into a case study here with one of our customers. So let's take a look at one of our customers that needed to quickly get remote patient monitoring products to market. And they needed to do this with a low touch approach. Healthcare providers are increasingly turning to remote patient monitoring between, also known as RPM, between office visits to manage patient care. And this is actually a use case that means a lot to me personally. I think to like some of my family members who really benefit from having access to care, even in the comfort of their own home. I have a family member who recently got to experience RPM for the first time and selecting out a product. So this is, really has the potential to improve quality of life. It's a really exciting use case. And in the case of Vital Health Links here, the customer that we're looking at, they fill this gap using monitoring equipment, and Hologram's cellular IoT secure connectivity is at the heart of their solution. That's embedded into their product. The Vital Health Links team is 100% remote. So they work with clinics spread all across the United States, health centers that serve rural populations. So they're a remote team. They're serving remote customers as well. And they needed devices that would work anywhere, that required little training, and that were very simple to activate. So with Hologram's pre-flight service, Vital Health Links rollout processes are ultimately very streamlined. Devices are tested and provisioned at the factory and remain in hibernation until they are activated. Then Vital Health Links incurs zero data charges, no matter how much time elapses before the patient's identified and they can ship this product. Hologram's global SIM activation is then simple. When a clinician turns on the device, it instantly establishes a private secure connection with the nearest cell tower, whatever that might be. And the patient goes on their way. And then basically people operating these devices and deploying these devices require no training or connectivity knowledge. Rather, they only need to know which device is assigned to each patient, turn this thing on, it can connect, it can do its job. At that point, the Hologram dashboard allows Vital Health Links to see when the device was connected or last used. So they can manage the devices across various partner clinics of theirs, their own customers. So Vital Health Links team members can easily access the information in the dashboard with minimal training, enabling them to scale quickly, even with a relatively small team. This is a great use case where Hologram's cellular IoT SIMs really shine with their unique qualities that wouldn't exist in a consumer-oriented SIM. Qualities like remote provisioning, having that Hologram dashboard for a single place to have complete visibility no matter what network you're connecting on to, and also the easy management. For another case study here, we've got a customer that needed to globally manage high volumes of data across the fleet of equipment. So this customer is Fieldin. They are the world's largest smart farm operations company for high-value crops. And they provide farmers visibility and valuable insights to improve farming efficiency. Key to their success is strong connectivity to support data transmission from machinery in the field where reliability can be difficult. These are all over and they often are in rural locations. The company has installed telematics IoT devices on over 5,000 farm vehicles globally. Each vehicle is equipped with a Hologram SIM card, which constantly feeds data into the cloud for analysis. Key to the success of their operations is live visibility on exactly where the machinery is driving, and also what has happened in the last shift, last day, last week, last year, etc. But reliable connectivity in agriculture can be challenging given that you're deploying in vast and often remote areas. And so FieldIn manages over 750,000 acres, by the way, which is really immense to think about. And different cellular networks may be the best choice depending on where you are, which field you're in, of course, which farm, but also even which field you're in. So different cellular networks, even in one area of a farm, could be better versus another. The choice of Hologram SIM allows the machines to switch between networks as required, and it ensures reliable performance, even with high data volumes. Having one SIM card, so one SIM SKU, also helps them to keep their costs lower and reduces the complexity of their system versus having to manage multiple SIMs or multiple SKUs. We're going to talk a little bit more about that as we dive into some of the technological differences between consumer and IoT SIMs soon. But continuing with FieldIn, their transition into fully autonomous farming requires even higher data volumes and ultra-reliable connectivity in order to support their equipment. Hologram SIM in their 5,000 plus machines worldwide allows them to ingest the data, investigate it, and better understand equipment activity, ultimately to perform better farming. Yeah, so we've looked at these two cellular IoT scenarios. So let's rewind for a minute and we can discuss a little bit of the difference between consumer cellular SIMs and IoT cellular SIMs in a little bit more detail. So I've actually worked with hundreds of customers, small and large, and I would say that the single biggest problem using consumer SIMs is scale. It's scale as you're trying to ship your product to more locations, more regions, more customers. That's when you're most likely to hit friction points when you're using a solution that wasn't purpose-built for IoT. So say you're a small business and you are managing 20 tablets deployed to a single city. Realistically, one IT person could probably manage that fleet, and you might even get away with a single carrier's coverage, at least to start. You might not notice too many hiccups using just a single carrier, single set of towers. But as you grow, and now you've got maybe hundreds of tablets in your solution, you're starting to ship to cities all over the world, even all over the same country, and now need multiple carriers, which means multiple contracts, integrations, multiple SIM SKUs, and therefore product SKUs. With more devices in cities, you have more surface exposure to these complexities. You also have more exposure to things like potential localized network disruptions or performance degradations, which happen from time to time. So at scale, what you really need is to have a central way to manage those devices and a way to roll out the appropriate SIM profiles right where they're needed and when they're needed, and using a single SIM SKU to do this. And then you have to keep track of all the device behavior and performance and how your devices are actually doing in the field. So starting with cellular IoT SIMs, basically right from the get-go, basically translates into less cost and less burden, less overhead, and ultimately less friction when scaling to new markets and to new customers. Having a SIM purpose-built for IoT reduces this complexity, and it provides a single pane of glass. And in the case of Hologram's dual-core SIM, for example, you can even have multiple profiles, autonomous profile switching to expand your coverage and provide contractually guaranteed uptime. These are things where if you're using a consumer SIM that has a single profile, you're not able to do. So let's talk a little more about consumer SIMs. I'm sure there are probably a few questions around consumer SIMs and can consumer SIMs be used in an IoT use case. We talked a little bit earlier about how the devices work, the differences between provisioning between IoT versus consumer SIMs. Let's talk a little bit about the why side of this. We sometimes hear from customers that it's challenging to know if and when to bring consumer SIMs into the market, and if there's a place for that in an IoT product. And I think that's a fair thing to be considering. There's probably a lot of confusion too, and a lack of knowledge about some of the new standards that are coming down the line, which we'll talk more about in the next slide. But just talking about consumer SIMs for a minute. For various reasons, a company building an IoT product might be considering consumer eSIMs currently. For one, they might start with a consumer SIM because it's familiar to them. They might even be using a tablet or some sort of an architecture where there's native support for that. But it's hard to move from a small set of devices with consumer SIMs and then get to the scale needed for business success. And we kind of already talked about that. Another reason is they might be attracted to the idea of local profile management, which is something that was introduced when the consumer eSIM standard came out. We'll talk more about that in a moment as well. For most organizations managing IoT devices, the remote provisioning and the ability to connect to multiple networks really makes cellular IoT SIMs the better business choice, because they're purpose-built for needs at scale. They're purpose-built to allow you to have instant-on connectivity, to change profiles if and when you need it, to be able to manage that connectivity lifecycle remotely. But what's exciting is that there are actually some new innovations in eSIM that combine some of the benefits that were introduced in consumer eSIM into a purpose-built standard for IoT, which we're going to discuss next. So let's talk about what's coming up next. There is a new standard on the way. So there's this SGP.31.32 standard that's on the horizon. And SGP.31/.32 is an interesting innovation. So the first thing to know is just that .31 and .32 are specification documents. They're closely linked to one another. And what these are doing is they're describing GSMA's new eSIM standard for IoT. You know, the GSMA, which is a trade organization in our industry, they're very thorough. And I personally, having read like every eSIM standard doc since the first, I can say that the GSMA really thinks about a lot of considerations when designing a standard for its intended use cases. To kind of understand, though, the benefits of .31 and .32, this new eSIM for IoT, first, it's helpful to actually rewind back and talk about M2M eSIM, which was the first eSIM standard, and then kind of talk about the progression from that point forward. So SGP.01/.02 are the specification docs that describe M2M eSIM. M2M eSIM is really all about remote provisioning and having a bootstrap profile to get you connected initially. That's what it's about. It's about not needing to physically swap a SIM when you need to change profiles. We were actually early adopters of EUICC eSIM technology here at Hologram. And this is because we understood this need for remote provisioning and configuration of SIMs without requiring user interaction in order to scale IoT deployments. Since SIMs are actually small computers, as we mentioned, they're not just memory. We've also innovated in this area over the years with software that runs in the SIM and works with our platform in conjunction to make sure profile selection happens seamlessly. That's our dual core SIM, which I mentioned before. That need for remote provisioning, though, for cellular IoT devices isn't really ever going to go away. And this M2M eSIM standard isn't going away immediately either. Under the hood, M2M eSIM uses mostly centralized and sometimes decentralized profile inventory, where you're storing those virtual profiles on something called an SMDP server, in case anyone's interested. But it's mostly centralized, somewhat decentralized. You fast forward in time a little bit, and SGP.21/.22 specifications came out, and these jointly describe the consumer eSIM standard. And consumer eSIM really came around as a result of consumer devices like iPhones, Apple Watches, et cetera, where the user wants to select a profile and provision that profile on demand to be able to connect their device to whichever carrier, whichever provider they're going to be working with. And consumer eSIM, as I already mentioned, consumer eSIM really relies on that user component. It's really designed for there to be a user present who can provision, and then if you're ever going to switch profiles, can re-provision. So even in the cases where consumer eSIM is occasionally being used in an IoT context or an IoT product, you then have the problem of, well, how do we trigger provisioning when we need it? Because that mechanism doesn't exist already in the SIM, since the SIM was expecting a user to be present to do that. That's like, of course, like scanning a QR code, or maybe in an IoT sense, providing a URL to the device. One of the benefits of consumer eSIM is local profile management, but another benefit under the hood is consumer eSIM uses a new type of profile inventory server called an SMDP+, which is distributed. So where M2M eSIM is centralized or slightly decentralized. The consumer eSIM profile management is distributed. That doesn't matter to a lot of people, but under the hood, that's very interesting for operators. So it's certainly an innovation on the backend side. So what we have with SGP.31 and .32, which again is the eSIM for IoT standard that GSMA has proposed, this combines the remote provisioning and remote configurability benefits of M2M eSIM with a little bit of local profile management and the use of the SMDP Plus, this new generation profile inventory server under the hood, and combines that into a single standard that still is purpose-built for IoT. So you don't lose, like you would with consumer eSIM, you don't lose your benefits of remote SIM provisioning when using this new standard. But consumer eSIM, which isn't purpose-built for IoT, lacks a lot of the functions that you might expect when trying to scale and deploy a fleet, which necessitates, if you were using that in an IoT product, that necessitates kind of reinventing the wheel or re-implementing a lot of what already exists in either M2M eSIM and or the eSIM for IoT standards. So the question that you might be wondering is, should you adopt .31 and .32 today, since we know this is a new standard, the new iteration of the GSMA standards? There are a few issues with it, with someone trying to adopt it today. One issue with adopting .31 and .32 today is timing. There are a number of providers out there that are talking about SGP.31 and .32 SIM offerings, and everyone's currently working on their solutions. But the final test plans and certification of this GSMA standard are still being worked on, which means that solutions today lack rigorous guarantees around interoperability. And interoperability is another way to say profile availability or coverage. In my opinion, we've seen the development of the new SGP.31 and .32 specifications occur at really a relatively high innovative pace. And as someone who spends much of his time under the hood in eSIM technologies, the innovations actually personally really excite me. So I'm looking forward to, these technologies coming out and hitting the market. But at the same time, you don't build standards like these GSMA and other industry standards that last decades overnight without a lot of consideration and collaboration throughout the entire industry. So right now, we're kind of in a phase where we're more in an evaluation stage of the technology, and several experts in our industry are predicting general availability of SGP.31 and .32 solutions to hit in 2025. And these are really hinging upon compliance, test plans, that interoperability. And like I said, although I think the GSMA is innovating very quickly with these specifications at a even more rapid pace than ever, there is a lot of work to get everybody on the same page all the way up the supply chain. And interoperability, again, means coverage, ultimately. Another potential issue is commercial access to the profile you need. So talking about this interoperability a little more, the most important considerations with choosing a SIM technology and a connectivity provider is, do these provide my device with an out-of-box connection preloaded? And will my device be able to connect where my customer is located, where the device ultimately is going? To do this, it requires both technical integrations and commercial relationships to support the entire connectivity solution, where technologies like M2M eSIM or eSIM for IoT are just one of the components. So even with remote provisioning, which exists both in M2M eSIM and eSIM for IoT, that's crucial. But it's really just one component to an overall profile logistics management solution. And it actually requires a platform and software to manage the provisioning when the provisioning needs to happen. So just using that as an example, there's a difference between having the technology and having a solution that can get your device connected. And in the case of eSIM for IoT, that profile availability is key. Related to that, though, there's also one technical limitation that is acting as a little bit of a blocker as well. So related to the preloading of profiles, there is another spec called SGP.41 that's currently being drafted to address how to standardize loading profiles during product manufacturing. Secure and efficient logistics around profile information handling is perhaps one of the biggest challenges to buying a consumer eSIM off the shelf today and using it in an IoT device. And it's also a big challenge to future concepts like iSIM, which we're not really talking about today, but are related. This lack of a standard around how to have a manufacturer that's building a product also handle these SIM profiles and somehow load those during manufacturing is a strong reason why someone building a product today should try to source their eSIMs from their same connectivity provider, their source of the profiles, to ensure that the profiles you need can be preloaded. Because if there isn't a standard governing how to exchange this information, basically there's an interoperability problem. That's a supply chain problem. It's a coverage problem again. So we're still a few years away from complete adoption of the new standards across the industry. And there are actually new integrations and deployments happening in the M2M eSIM spec. That's the .01 and .02 spec. But it is great for our customers and the industry for innovation in eSIM like .31 and .32 to be continuing as it has. And then we're going to open it up for some Q&A.
Thanks so much, Pat. We have quite a few questions. I think you kind of hit on the first one that we received in your last part, talking about .31 and .32. But as you mentioned, there's some companies out in the space right now that mentioning you can buy .32 SIMs. There's a question if you can clarify where the market is on SGP.32 eSIMs. And I think the easy way to answer that is, we're a couple years out. We'll see some form of GA in 2025. And then obviously it'll kind of sprawl from there as far as adoption is concerned. Is that kind of a good assessment that we're roughly a year out?
Yeah, I would say so, because there's the eSIM technology, and then there's further up the supply chain is the MNO adoption. The thing that is working in favor of .31 and .32 is the fact that it uses that same DP Plus server for profile inventory management as consumer eSIM. So, the engineer in me says, oh, that sounds great. You've reduced code and complexity by combining things. That sounds good. The reality is different MNOs are at different stages of still even consumer eSIM adoption, but also figuring out how to place IoT-oriented profiles in their inventory and distribute in this mechanism. And it still doesn't fix the fact that you need to actually have commercials to provide the coverage. Having an API somewhere that you can't access is not useful. So the problem is that there are multiple moving pieces. And so the good news is that there's been a lot of rapid development effort on innovating and designing these new specs. And it also uses builds upon some technologies like the DP Plus server that already exist and are tested. But that doesn't mean that IoT-oriented profiles, APIs, and all the commercials and all those other pieces are aligned. So even when eSIMs that support .31 and .32 come out to general availability, there's still going to be some time. So I think a year out before we see a lot of market traction is accurate there.
All right, awesome. Just got a follow-up question to that, specifically about roaming features. Is there anything that you can address that as it relates to .31 and .32?
I'm not positive on if the question is asking more about connectivity roaming, like cellular roaming, data roaming in that context, which still is supported just the same, or if it's addressing something else. So maybe we can get a follow-up question from that same person.
Yeah, for sure. We'll back pocket that for a moment. Well, one of the first questions that we received was in relation to using cellular IoT in remote areas. Like the case study or use case rather that was mentioned was mining, like limestone and coal mining operations. Do you have a perspective on how cellular IoT can help benefit those type of businesses?
Yeah, what we have often seen in what I would call the remotest of applications. So this can even be, this can be as remote as farming, but it can even be a little bit more remote, like if you're going underground and out of range of a cell tower. What we've often seen is a kind of a hybrid model where you may deploy a network on site and then use cellular as the backhaul to connect to the internet. So cellular provides like your last mile connectivity to your site, and then from there you might have your own private network. And in that case, it's really cellular backhaul in a remote location is a very similar use case to like that farming case study that we looked at. And in that case, the needs are similar. It's, do you have multi-carrier access so that if you're kind of on the fringes of cellular coverage, you can connect to the tower that you need to best serve that location.
Awesome. Thank you for expanding on that. So there's a question related to just data transmission limitations on the hologram side. The person asked that they have a client that scans images on a continuous basis, huge amounts of data. Do we at Hologram have limitations for this specific use case as it relates to data?
That's a great question. So the short answer there is there's no reason an IoT SIM would create a limitation. You're really talking at that point the core networks, the profiles, what is your path to the internet? And one of the things that Hologram has done with like our dual core SIM, for example, is we've created a way to provide multiple profiles on a SIM. Through our dashboard, you can see what's active. You can also manage which profile is active. That allows your device to connect to various different core networks. So what this looks like in this sort of a use case is, you're not just concerned about coverage in this case. That is, can you connect to a tower? You're also concerned with what's the most optimal path to the internet. And that's a problem that we have been working on a lot with our higher data use cases. We have a number of security camera customers. We have actually some remote patient monitoring use cases use two-way video. And those sorts of really innovative IoT products have started to push what traditionally was considered low data. People used to think of IoT and equate that with like telemetry. It's really started to push things in higher use cases. And so what that does is it necessitates adaptability at the SIM card so that you can choose the most optimal path to the internet, which can vary based on where that device is being deployed. And that's something that is something that we've actually specifically worked on. So for that, I would say, for like more detail, it would be a good thing to kind of talk to sales, and we can look at the use case and match it to similarly profiled use cases. And when I say profiled, I mean in terms of network load. But yeah, that's actually very common today to see real-time video and all other higher data use cases, or even mixtures where you have telemetry and then sometimes higher data for more advanced use cases.
Thank you, Pat. We did get clarity on the roaming feature question. It was specifically about the interoperability between two different operators.
Okay. Yeah, so that's a great question. The .31, .32 standard, if you were to have profiles from different providers, that's not in theory an issue as long as like commercials can cover that. One of the nice things with the distributed profile inventory management is that it makes possible for some like less hierarchical, I guess is how I'd put it, relationships to exist. One of the challenges though is there can only be, even in .31, .32, like .01 and .02, there can only be one platform at a time doing remote management of your SIMs. And this is mostly for security reasons. You don't want someone, stealing the SIMs away or something like that. So there are mechanisms to set that, to configure that on the SIM, but you can only have one remote management at a time, even though you can, if your commercial relationships support it, have profiles from a number of different sources. You can only have one. It's called an EIM. It replaces the RSP, or remote SIM provisioning element, in .01 and .02. You can only have one of those servers tied to that SIM at a time.
Okay, awesome. We have a question specifically around industrial IoT as it relates to eSIM. The person asked, can we use eSIM for industrial IoT for collecting machine data to analyze within their manufacturing operations?
Yeah, we've seen, so it sounds like you might be describing more the actual equipment doing the manufacturing, and we see cellular often used for industrial IoT. It's easy to think during manufacturing, it's easy to think that deploying your own network could be easy if you're in an enclosed environment. But the reality is, when you're talking about a large enough factory, or if you're sending devices to contract manufacturers, and we've actually built devices at Hologram too, so we have some firsthand experience with this. If you're sending your own programming hardware and test hardware that you've designed to your contract manufacturers, you don't always have access to their networks because you are not always the manufacturer. So we often see cellular, whether it's just because you have the instant on connectivity, or you have like a multi-tenant environment where the person doing the manufacturing on behalf of a company is not the same one who's manufacturing the devices. In those sorts of environments, you see cellular connectivity being used. Another thing is that, and then we see this with products actually being manufactured, we'll provide a bootstrap profile and something we call pre-flight mode, where you can have your product manufactured and have cellular connectivity right off the manufacturing line to do like self-tests, or maybe at your fulfillment center to do further provisioning or testing before sending to the customer. So that's also a common use case where you're maybe looking for connectivity right at the point of manufacture.
All right, awesome. We have a question here. It states, from the embedded code side, what do I need to add to the product to support the eSIM?
That's a great question. So thank you for that, Mark. So the eSIM today always makes use of a separate chip to implement it. So whether it's EUICC eSIM that's being used for M2M or for consumer or for .31 and .32, it's a separate component today. Now the iSIM, again, we're not really talking about that today. iSIM is all about, can you consolidate components and really embed that functionality? But since that's not really it's not market ready today, you don't have, iSIM doesn't support a lot of these features like we talked about, you can almost ignore that. And anytime you're talking about eSIM, you're always talking about a separate chip. And there's some benefits to that. One of the benefits to having a separate chip is that chip has gone through rigorous quality control, and it has very tightly defined interfaces. And the eSIM functionality is actually outsourced from the rest of your device stack into that chip. So that chip, the eSIM component, whether it's plastic or it's soldered into your device, either way, implements all of the eSIM standard and then just works in conjunction with your modem for communication. So, when eSIM was first coming out, there were some interfaces that needed to be built and supported by modems. But nowadays, the interfaces basically universally exist. So you can take an eSIM and connect it to a modem that's expecting a SIM card, and the eSIM functionality is implemented in that SIM. And then if it's M2M or the future .31, .32 standard, the IoT eSIM, either one of those, that can then talk to your platform that is providing the remote provisioning. So you don't have to code the functionality. There are some considerations around, not, if you're powering up the device and connecting, providing a duty cycle that allows for a profile download. Profile downloads can happen very, very quickly. But if you're talking powering up for seconds at a time and powering down, there may be some considerations there, but that's about the only, it's sometimes a duty cycle consideration. That's about the only consideration that typically a developer needs to think about.
All right, great. Another question here. Is it possible to load hologram profiles onto an EUICC initially provided by a different MNO and soldered on a custom IoT product circuit board? Do you support such migration?
Yeah, that's a great question. And this sort of scenario can come up from time to time. In the M2M world, M2M eSIM world, that requires getting our profile inventory. Well, you're saying here initially provided? Okay, yeah. This answer is correct. What it typically requires is us getting our profile inventory onto a third party's profile inventory server called the SMDP server. So that's a possibility, but it requires some cooperation. In .31, .32, there'll be a little bit more profile portability because of the distributed nature of that inventory. So it'll look a little bit different. It'll be possible basically to download a profile directly in the future without having to have cooperation with an existing provider. That's another one that would be good to talk to sales about, because it depends a little bit about the specifics of what type of SIM is in use and who that other provider is.
All right, fantastic. I'm just going to take a quick look to see if we have any other questions that we haven't answered yet. So here's a question from Nigel. Can you elaborate a bit more on higher data usage, higher data use cases? We have video streaming and have not been able to find a partner willing to embrace the project amount of data. I think this one is definitely a part of our strong suit, and I'll let you elaborate a little bit more on.
Yeah, we're very familiar with the video streaming use cases, and we're often localizing, is what I would call it, a profile to give you some regional performance benefits, also pricing benefits by trying to route your traffic as efficiently as possible. That's a great one to talk to sales about, but we are supporting a number of high data and video streaming applications. So that's a great one to have a conversation with sales about. And it's a common use case these days, whether it's fixed point streaming or it's, you setting up temporary in one location or another. Both of those are increasingly common use cases for IoT today.
All right, great. I see that Felix has raised his hand. We'll get to you in one moment. We have one question before you from Craig. Do the new eSIM standards allow for OTA software updates, or are they locked as of the version at the time of issue? And he's specifically referring to the on-SIM software.
Yeah, that's a great question. So as I mentioned before, SIMs are little computers, so they run an OS. And in fact, in many ways, an eSIM with EUICC capabilities is almost like running a virtual machine for a SIM, in some cases at least, or a container, maybe is a better analogy. And so you have an OS layer that's providing functionality, and then you have profiles that can be active. But eSIMs typically do not have a lot of memory. So the vast majority of eSIMs cannot have their OSs significantly updated. They can have additional applications installed. That is possible, but they often cannot have their core versions upgraded. They just don't have, basically they don't have a bootloader beneath the OS. And a lot of that has to do with the amount of memory that's available. So it's still, while they're very capable, and it's actually kind of cool, like some of the things you can do inside of a SIM card in terms of software, they are still a very resource constrained environment. And that does limit the jumps up significant specification versions like your question is asking about.
All right. Thank you, Craig, for asking that. Really appreciate all the thoughtful questions that were asked. I hope Pat was able to give you some good answers for the queries that you had. And certainly reach out to us if you should have any additional questions after the webinar concludes. We are trusted advisors in this space. We want to help you be as successful as possible in IoT. With that said, we thank you so much for spending some time with us this afternoon. It means a lot. We know how busy everyone's schedules are, and we're certainly appreciative of you spending some time to learn more about what's coming down the pipeline with eSIM technology.